Hello everyone, hello again, and thanks to be part of this TTK tutorial. Now we will see how we can segment medical data using merge trees. First, I will give you some context by explaining what are the data we are manipulating and what we want to do with them. We want to extract some preeminent features in the dataset, and for this, a usual pipeline with TTK is to simplify the dataset so we keep only the numbers of features that we want, and then we compute a merge tree to get the area corresponding of these features, and we have a look at the segmentation of these trees to visualize this area. The dataset we are manipulating is a scan of a human foot, on which, on each point, the scalar value is the density of matters in this position. A point with a low scalar value can correspond to the air around the foot, and the point with the highest scalar values will correspond to the bones inside the foot. Let's open this dataset. We are only interested in the scalar field named scalars, and apply. If we want to have the same view as in the slide, we can use the volume representation. So now we want to extract the area corresponding to the bones of the foot, and if possible, we will try to identify each toe. For this, we need to extract area attached to the maximum values of scalar fields, as bones are area with a really high density of matter. We can use a merge tree for that. But if we compute a merge tree directly on the dataset, we have a lot of noise. So to reduce this noise, we will keep a dataset with only 5 maxima. We will simplify this dataset using a topological simplification, and then we will compute the split tree on it. Let's do together this topological simplification. We want to keep the area attached to the 5 most persistent maximum. Let's compute a persistence diagram to see how many features we have on the dataset. We can use the default properties here. Here is the persistence diagram that we obtain with a lot of pairs. We want to keep only the 5 most persistent pairs. For this, we will filter our persistence diagram using a threshold, but what is the value that we want to keep only 5 pairs? We can have this information using the persistence curve. Here is the persistence curve on the foot.vti, which shows you for each persistence value how many pairs are in the persistence diagram. And we can see in this curve that to keep only 5 pairs, we need a threshold of 187. Let's try this. I want a threshold on the persistence diagram using the persistence, and I want to remove all the pairs below 187. Here is the result. If I look in the information, I have 6 cells, and I want only 5. This is because I also have the diagonal, which is a bit a virtual pair. So I want to remove this diagonal, and that can also be done using a threshold, and the result on my first threshold. And the diagonal is a specific pairs with the identifiers -1. So let's remove the pair with the identifiers -1, and I obtain my persistence diagram with 5 pairs. Now we have all the information we need for the topological simplification. Topological simplification is the TTK filters that will operate on 2 inputs, the domain, which is the foot, and the constraint, which is the resulting persistence diagram that we have just computed. So let's call the topological simplification. The domain on which we want to operate this simplification is foot.vti, and the constraints are the threshold we have just computed. Properties. Here we can use the default values. Now I have a new version of the foot. We don't see any difference, but the noise has been removed, and that we will see by computing a merge tree. We have said that we want the merge tree with leaves corresponding to maxima, so this is the split tree. In TTK, the filters that you can use to compute contour trees on merge trees is named FTM. In the properties, we select a split tree, and we can compute it. As we can see, the result is a tree with only 5 leaves and 1 root. Now, let's extract the area corresponding of the leaves. For this, we need to get the region which are attached to the leaf, and these regions have a region type of 1. Once again, we will use a threshold to get them. So on the segmentation output of the FTM tree, we want a threshold using the region type with a value of 1. Apply. And here we have our results. Thank you to have followed this presentation.